how healthy is it to blast humans with the infrared light?
Of course.
Eye safety, you mean?
You wouldn't use the visible light because you will
Sure.
what's it called, interfere with the just illumination of the room. You would use infrared.
Yes.
And also you can boost it a little bit, but then your whole skin, eyes also exposed.
Of course, whatever we say is within the standards,
Yeah.
the eye safety limit, because in our own universities, the laser safety officer, they check our laboratory regularly. If they come and do measurements, if they find there are light sources which are beyond that, they will just shut the laboratory down, because that's a legal thing, so we cannot expose. So whatever we say is within that framework. But I didn't rule out the VLC. I said that VLC and infrared go hand in hand, because you have dimming. Some people like to work at dark. So what happens then? Then you have to have an infrared LED within the light source.
Yeah.
So you can turn that on, and then since you are using what we call a diffuse light, so the safety is okay, but also it's a common practice that we tell students that when you're working with light, never look at light directly. Even our optician says that when you're out, it's sunny, wear sunglasses. So those things we know it. It's a common knowledge, and we will adopt that. Yes, and of course there is a difference that if you operate within this room at ceiling height level, in order to link one room to another and so on, then you can have laser beams, which is the ceiling height. No one is going ever to expose themselves. So you can basically rip up all these internet cables and just fire one laser through building a little hole from one room to another, split the image. Those are sort of things people are looking into in some laboratories. Yes, replacing the cable-based internet by FSO-based internet.
And you mentioned eye safety, Lev, which is mostly a problem, certainly in the near infrared. Your eyes don't respond to it, your pupils are wide open, and then you get wavelengths in that still could focus on your retina. And what in your group you would certainly say, yeah, but the whole telecom world, and with telecom I mean then the fiber world, is using wavelengths 1550 and so on. And those do not go through the eye. So it is.
So the eye safety for this kind of wavelengths is quite high. They are absorbed in the vitreous body of your eyes, and therefore is that this longer wavelength is much more interesting for us to work with that.
Yes.
And also what I need to point out is that, for example, in FSO outside, we are with atmospheric turbulence, also the weather conditions. So people are all starting to using at a longer wavelength, much longer, 5 micrometer or even longer, just to avoid this kind of this. And then with longer wavelength, then your eye safety become also a high threshold. Mm-hmm. So that is the
just a point on the safety. We have from optical fiber communication, we learned something. There are 3 transmission windows. Yes. Around 850, then 1300 and 1550. Then if you bring the visible light, then you have 4 transmission windows because you have got the visible band. Okay, the visible band is of course where the eye sees things, and that's where also you have the sun as a background noise. So as soon as you move away from the first band, which is the visible band, to either the first or second or third transmission window, the effect on the eye gets less and less. But of course, it makes sense that we operate on, let's say, 1550 because that is the backbone compatible, or 1300. Your comment on people are moving to much higher. And in fact, this idea was discussed. I remember that we had the first meeting in 1992 in Institute of Physics in London with a lot of physicists, communication engineers, and so on. And the idea was that should we use at 1550 or move to beyond that? But what colleague was saying that, yes, you can do that, but the devices are so costly and expensive and so on, and that's why it's holding back. But now I believe that things are getting more available and maybe low cost and so on, and possibly that eventually FSO will try to shift that. But I'm not sure about the fiber because it's lost characteristics and so on. But for FSO, certainly to deal with turbulence and so on, it makes sense to push the wavelengths to much higher. And for backbone, high data rate, the cost is not that important because the revenue generated by shifting, hundreds of gigabits of data is so huge. Investing in devices is not a problem in my view.
No, exactly, because the sharing factor that is so high.
Yes.
We share with other components, other users, other networks, so the device can be expensive but should be reliable.
Yeah.